Hi everyone, this is Mr. Hall, and this is just a short video about how to calculate instantaneous rates. Instantaneous rates is really different to calculating mean rates, particularly from graphs. So hopefully this video will show you a little bit about how to work out instantaneous rates from graphs and highlight the key differences with calculating those against how you do mean rates. There's 4 things you always have to do when you're calculating instantaneous rates from graphs, and I've described them just here. So the first thing you always do is they will ask you calculate the instantaneous rate on this graph at a particular time. It might be at 2 minutes or 50 seconds or something like that. So the first thing you do is you work out where the time is, and then you draw a tangent at the time that you've been given. All right, and it always has to be right on where that point is. Now, as soon as you've got that tangent, you then have to work out what the gradient is, and that gradient is effectively the rate of reaction at that point. So to work out the gradient, there's 3 steps you have to follow. The first one is to work out the difference in mass or volume, and that's of the product that you've made. The second thing you have to do is you have to work out the difference in time. And then the final thing you have to do is you have to calculate the rate, which is effectively the gradient that you've got. So I'm going to go through a couple of examples just to show you exactly how this should look when you're laying out your work. All right. So this is one example that you may get, that you might come across. And the question in this case is calculate the instantaneous rate at 3 seconds. Now, if you recall what I mentioned before about the 4 steps, the first step we have to do is we have to draw a tangent at the time we've been given. Now, we've been given 3 seconds. So the first thing I do is I find 3 seconds. I'm just going to put a cross there just as a mental note that I have to draw a tangent at that point. I'm then going to draw a tangent. Now, I don't have a ruler here, so it might look a bit rubbish, but I'm going to have a go at drawing as straight a line as possible. My pen's playing up, so I've got a weird spike there, but ignore that. And that more or less is my tangent. I know it doesn't look very good, but you would draw a better one with a ruler. Now, once you've drawn your tangent, you can then do the next few steps. And this is all about calculating the gradient. So the first thing I have to do is I have to work out the difference in mass or volume. Now, in order to facilitate this and make it as easy as possible, I want to choose 2 points which are reasonably easy to read on at least one of the axes. I like reading it easily from the y-axis. You might prefer from the x-axis. Doesn't really matter. But I'm going to choose this point here because it looks quite convenient because it matches both. And I'm also going to choose, let's go for this point here. And it doesn't really matter which 2 pairs of points you choose. You're not going to get a different result as long as you work out the gradient properly. All right, the gradient will always be the same along this tangent that you have. So now that I've done that, I need to work out the difference in mass or volume between these 2 different points. So let's start with this point over here. Now this point, if I just draw a line across here, to where that is, you can see it's right up against 45. So I'm just going to write 45 here. All right. Now I've also need to check my second point, which is here, and that correlates with 15. So the difference between the 2 is 45 take away 15, which in this case is 30. All right. Now that I've done that, I need to move on to my third step. My third step is to work out the difference in time. Again, I'm going to choose the identical points which I've chosen before. And again, I'm going to annotate my graph, I'm going a bit wonky, with these 2 different points. Now that is about at 6 seconds. So I'm just going to write the number 6 here. The next one, which is this, I'm just going to again draw a line down. Now the examiner quite likes seeing these annotations. So always draw these annotations to show you get it. Now this is more or less at 1. So to work out the difference between 6 and 1, I do 6 take away 1, which equals 5. So what I've got is 30 divided by 5. Now, if I put the units in, for volume, it's centimetre cubed, as you can see on the y-axis there. And then for the 5, that's seconds, as you can see over there. So I've got 30 divided by 5, which equals 6 centimetre cubed per second. Now that is the instantaneous rate. This is very different to the mean rate. If I wanted to work out the mean rate at 3 seconds, it's a lot easier. I just have to go to 3, read off the volume at that point, which is 25. So it'd be equaling 25 divided by 3, which would give me a different number, which if I just check my calculator, can't do it in my head, would give me 8.33 centimetre cubed per second. So you can see that the 2 numbers are very, very different. So it's important that you get this right when you're asked to do it. Now, if we try a different example with the same graph, instead of 3 seconds, we're going to try it at 6. Again, it's the same procedure, except we're doing it at different times. So we're going to do it here at 6 seconds. I follow the first step, which I was given before, which is to draw the tangent. So I'm going to draw a tangent here. Again, when you do it, please do it with a ruler. There we go. I now need to start constructing my equation for my gradient. So the first thing I want to do is I want to work out the difference in volume or time. Before I do that, I have to choose two identical points. So I'm going to choose this one here, and let's choose this one here. So to work out the difference in volume, I'm going to have to draw a cross. That's my first one. And I'm going to draw across my second point. Now this one, more or less, it's at around 43, let's just say for the sake of argument. When you do this with proper graphs in exams, you'll get much finer lines, so you actually get much more kind of precise figures. I look at my second point here. This is around 28, so I'm going to put 28 there. Now I need to divide that by the difference in time. Now if I look at the time value here, I'm just going to bring it down. That's precisely at 9. And then if I look over here, and then again I draw down, that's at 3. So the difference between 3 and 9, 9 take away 3, that's obviously 6, and that's seconds. The other one, which is 43 take away 28, equals 15. Ooh. So the calculation I've got is 15 divided by 6, which in this case equals, oh, that's not right, 15 divided by 6, oh, 2.5. And again, the unit, it's centimetre cubed divided by seconds. All right, let's go through one or two more examples. So this is a very different graph. You can see this is far more precise now. Okay, you've got this really fine kind of cube lines, reminiscent of what you see on graph paper. This is typically what you're going to be dealing with. Now, we've been asked to work out the instantaneous rate at 4 minutes. The bottom axis is measured in 4 minutes. The 4 here is covered because of my little box, but that's not a problem. So the first thing I have to do is I have to draw the tangent. Now, this is at 4 minutes. Let's go up to 4 minutes and let's do a cross right there. The next thing I do is I draw a tangent at that point. Now, remember, it has to be flat out against it. A couple of things about tangents when you're drawing them. Firstly, make sure they do not dissect the curve. I've been teaching quite a few classes recently, and quite a few of the students I teach, they always make their line dissect the curve. Try to avoid that, okay? You shouldn't be cutting in like that or like this. That's not what you want, okay? You want to make sure it kind of goes flat out. It's almost as if your tangent is balancing on the curve like that, okay? You want to make sure you've got that kind of fine line, and that will give you the best results possible. So now I've done that, I now need to choose 2 points in order to work out the second step, which is the difference in mass or volume, okay, which is over here. So in order to do that, let's choose 2 points. I'm going to choose this one. That looks like a really good point. And I'm going to choose this one here. Okay, so it's up to you which 2 points you choose. It's depending on what you find easiest to analyze, to be perfectly honest. So now I need to work out the difference in mass. So to do that, I need to draw 2 lines going across. So that's my first one, which is at 80, which is a nice number. And I have to take away this one, which is at 40, another nice one. So I've got 80 take away 40, which equals 40 centimetre cubed. All right, that's my first bit of calculation. The second bit I have to do is I have to work out the difference in time. So again, I have to draw a line down, like so. And that's at 8 minutes. And I have to work out the difference from here. Now, this is a bit more complicated because now I need to work out the value of one very small block. Now, each 10 blocks is 4 minutes or 240 seconds. Okay, so 10 blocks equals 240 seconds. Therefore, I've only got one block that I want to know at the moment. So one block must equal 24 seconds. Now, if we look at this very carefully, this is 1, 2, 3 small blocks along. So there's got to be 3 lots of 24 seconds, which in this case is 72, I believe, 72 seconds. So I've got 8 take away whatever this number is, 72. Now, to make this easier, I'm going to convert it all into seconds. So I'm going to have 72 here, and then 8 minutes, I need to put that in seconds, because I need to make sure the units are consistent. So it's going to be 8 times 60, which is 480. So, okay, So I've got 480, it's quite convenient, it's an 8. So 480 take away 72, which I think is 408. Okay, so I've got 40 divided by 408, and the answer here would be 40 over 408, and that's quite a long decimal number. In this case, it's 0.0980 centimeter cubed per second. All right, you're never going to get any axes more complicated than that. Most of the time, they're going to give it to you in seconds, but if they do give you something nasty, that's how you deal with it. So that's how you do it. I hope this has been useful, and I hope that you will go and be able to calculate this on your own. Just remember that when you're doing instantaneous volume, it's very, very different to mean volume.